All right, let's do a little bit more learning about types of reactions. So we've already studied the combination, decomposition, and combustion. So the ones that we haven't talked about are single displacement and double displacement. So let's do that right now. In a single displacement reaction, if A is a metal, it kicks out another metal. So now that poor X is all by itself and A has stolen its spot. It can also happen where a non-metal can kick out the non-metal. And so now that poor Y is by itself and B gets to be with metal X. Note that this can only happen if the element trying to kick out the other one is more reactive. Okay, and there's a activity series that tells you about what is more reactive. So like lithium is the most reactive metal. It can kick out anything below it, whereas gold is the least reactive. So it can't kick out anything. It can only be kicked out. And then for the halogens, fluorine is the most reactive, then chlorine, then bromine, then iodine. And if a reaction doesn't happen, like if we said, okay, gold is Au and it's trying to kick out lithium, well, it can't. So you would just write Nr for no reaction. And then here's some examples. Here, sodium is trying to kick out copper. So we check the chart. Is sodium higher than copper? Yes. So sodium can kick the copper out. Now copper is by itself, and now sodium is with the NO3. Now it's a new relationship, so we have to check charges. And since they cancel out, it's just NaNO3. No, don't worry about the numbers out front. We'll learn how to balance reactions soon. Okay, let's look at the next one. I know lithium can kick out anything since it's at the top. So yes, aluminum is by itself. And now lithium is going to be with nitrogen. Lithium's a +1 charge if you check the periodic table. And nitrogen's a -3. So when they crisscross, it becomes Li3N. Is chlorine more powerful than bromine? Okay, because chlorine is a halogen. Yes, it's above it. So now bromine is by itself, but it's in Hofbrinkel, so it always gets a 2. And now lithium is going to be with chlorine. Lithium's a +1, chlorine's a -1, so we no longer need that 2 that was there because the charges cancel out. So it's just LiCl. And then here's an example of a no reaction. Copper is trying to kick out sodium. Well, copper is below it, so that can't happen. So Nr for no reaction. Okay. I guess there's another example. I was like, what is this? How would you know that copper has a +2 charge? This isn't the best example. We would have to be told that copper is a +2 charge. So here it is. It's more powerful than silver. So silver is by itself now, and copper, which has a +2, is with nitrate, which is a -1 on the polyatomics. So when we crisscross, we need parentheses and put a 2 outside. Okay, double displacement is like you're dancing with someone and your friend's dancing with someone, and then you swap partners. Okay, the metal swaps with the metal, and the non-metal swaps with the non-metal, basically. So the reason why this happens is there's a driving force. It's either because a precipitate is going to form, water is going to form, or a gas is going to form. Okay, now there's a helpful table to tell you what solids can form. So just to be clear, soluble means it dissolves. No solid. And not soluble means a chunk, a solid chunk. Okay, so for example, if you've got silver and chlorine combining, it forms a chunk, a not soluble chunk. Okay, so, that's actually the example. So check this out. NaCl is reacting with AgNO3. So the Ag and the Na are going to switch places. The Ag is now with the Cl, charges cancel out, and the Na is now with the NO3. This doesn't have a label yet. Sodium is right here, and NO3 is right here. So that's soluble. So that means AQ, soluble in water. Whereas the AgCl, which we already pointed out, is not soluble, so it gets an S for solid. Okay, here's another one. H is switching places with K. So now K is with Cl, and let's check KCl is soluble, so that gets a little AQ. And H is now with OH, and that's water. So that was the driving force for this one. All right, Ba in this one is switching with the Na. So now the Ba is going to be with the SO4. Barium's a +2, sulfate is a -2. And then let's check the chart. Ba would be in the alkaline earth metals, and sulfate is here. And so it says it's soluble. I don't know if that's actually true though. Maybe it counts as a heavy metal because it's pretty, yeah, I think barium would be here. That makes more sense because this would be the solid. And then Na is now with the NO3 since it's swapping places. And that is soluble, so that gets a little AQ. All right, now it's your turn to try some. Use the activity series to help you. Can aluminum kick out copper? Aluminum is right here, and it's above copper, so yes, it can. So copper is by itself, and aluminum is now with chlorine. So this would be AlCl3. Copper is a solid, and this is a single displacement reaction. Let's look up. Aluminum's not on here. Aluminum chloride would be soluble, so it would be an AQ. Okay, don't worry too much about the phases in single displacement reactions. It's more focusing on, can you use the activity series? All right, can gold kick out lithium? Gold is down here, lithium's at the top. That's definitely a no reaction. Can bromine kick out iodine? Yes. So now iodine is by itself, but it gets a 2 because it's a in Hofbrinkel. Barium's a +2 and bromine is a -1. And so this is BaBr2. And then we've got, let's see, iodine is a liquid, and according to this chart, barium bromide would be not soluble. And this would be aqueous. They should have the phases labeled if they want us to do the phases. And our last one here is calcium strong enough to kick out iron? Calcium's here, iron's way down below it, so yes. So now iron is by itself, and calcium is with oxygen. Calcium's a +2, oxygen is a -2, so those two cancel out. Iron is a solid, calcium's a solid. This must have been aqueous. And then calcium oxide. Of course, they don't give us that. Calcium oxide, I believe, would be a solid. All right, Now we're going to use the solubility table with some, actually this might actually dissolve. Let's use Google since that one's not on the chart here. Is calcium oxide soluble? So yes, it is. Okay. All right, let's use this table. NH4OH, is that solid or aqueous? So NH4 is here, OH is here, so that would be soluble. CuBr. CuBr is soluble. FeS. Fe is here, S is here, so that would be not soluble. And K2S, K is here, S is here, that one is soluble. Okay, complete the following double displacement reactions and label their states of matter. Note, Ag has a +1 charge. Okay, so Ag is swapping places with Na. So now Na is going to be with NO3. And now Ag is going to be with Br. NaNO3 is soluble, so this gets a little AQ. Make some space there. And AgBr, here's AgBr, not soluble, so that gets an S. Okay, next one, K is swapping with Sr. So Sr has a +2, and that is now with SO4. And Sr, SO4 is soluble. Plus K is a +1, and I is a -1. K is here, iodine is here, it's soluble. So this reaction doesn't have a driving force, so I don't know about this one, to be honest with you. I think it's maybe, let me look at something real quick. SRI2. Yeah, not likely to happen. Okay, so good practice. Li swapping with NH4. So now NH4, which has a +1, is with chlorine. And that one is aqueous. Check the chart. NH4 is here, chlorine is here, so it's soluble. And then we've got Li +1 with NO3, which is a -1. This one is also soluble. So another one that doesn't have a driving force. So it's not really going to happen. Okay, next, K is swapping with Ba. So now Ba is with CO3. That's a +2 and a -2. So Ba is, that's right, we added it onto the end. And then CO3 carbonate is here, so that would be not soluble. And then we've also got K forming with Cl, and that one is soluble. I was going to say, didn't we already do number 13? We did something similar. Li is now going to be with Cl. The charges cancel out. And Na is now going to be with NO3. Once again, the charges cancel out. And those are both aqueous, so that one is also does not have a driving force and won't happen. And then Mg is going to swap with K. So now K is with the SO4. And let's check. SO4 with a K is soluble. And now we've got Mg +2 is with carbonate. And let's check that one. Mg with carbonate is not soluble. go. All right, so now at least you've been exposed to single and double replacement reactions.